Okay. Now let's move on to the feedforward neural network. That's the second on your slides here. So there are three types of neural network. We will start from the basic standard neural network. Sometimes people also call it feedforward neural network because of the direction of the neural network and the structure. Let's start from the very beginning, get to a little bit history of neural network. The very naive and early version is called Perceptron. In 1943, McCulloch and Peets published the first concept of a simplified brain cell to understand how the biological brain works to design artificial intelligence. That design is called MCP neuron. It's very similar to the neural network. The neurons are interconnected nerve cells in the brain that are involved in the processing and transmitting some kind of chemical and electrical signals. They describe a nerve cell as a simple logic gate with binary output. Multiple signals arrive at the dendrite are integrated into the cell body. If the accumulated signal exceeds a certain threshold, an output signal is generated and that will be passed on by the axon. So the whole process is very similar to the neural network. In neural network, we have an activation function, and it feels like the logic gate. If the signal pass specific threshold, and then you will pass the signal to the next layer of neural network. So based on this early MCP in 1957, the first concept of the perceptron learning rule was published. The algorithm learns the optimal weight coefficient that are then multiplied with the input feature in order to make the decision of whether a neuron fires or not. So in a classification problem, you can see this in a very simple classification problem, two class. If you have two class, you note it as -1 or +1, one for each. And then you have two features to predict the class of the sample. So you have a weighted average of these two features. You have W0 plus W1, X1, and W2, X2. And you have the a linear combination of this and get ZI. ZI is your signal, aggregated signal. And then if the signal larger than the threshold, you will classify it as 1. If the signal less than a threshold, you can say it's classified as -1. And the threshold here, I use 0 here, but you can use basically any constant number and just change the way you get the weight, but it doesn't matter what constant number you use. It will just change the W0 you will fit here. And you use this to predict. So how do you optimize this model, this very naive model? You can start with some random weight. Then you set a maximum number of epochs. What is epoch? Epoch in neural network, you use the sample multiple times. Once you use the sample one time, it's an epoch. And the second time, the second epoch. So it's basically a definition of how many times you want to use the sample you have. So you set a maximum number of epochs of M, and for each epoch, you start from the first sample, the first point I. Calculate, since you have initialized the weight, you can calculate the ZI from the input X. And if you check if ZI is larger than 0, you predict as 1. If less than 0, you predict as -1. And now you have your prediction. After that, you can update the weight by those following equation. It's actually a mini version of gradient descent. Basically do derivative with respect to W0, and you get the derivative is actual I, that's the actual value of I, it's 1 or -1, and minus the prediction. And you update the W0 by the previous W0 plus the learning rate multiply the gradient descent. And similarly, you can update W1 and W2. And then you calculate the accuracy of the entire data set to see if it meets a specific criteria after each epoch. If it meets the criteria, you stop the process iteration. If it hasn't met the criteria, you continue until it meets the criteria. So this is the very early version of the neural network. It's called Perceptron Algorithm for a classification problem. And this perceptron algorithm is very easy to implement in any modern programming language. We have R notebook here, you can, if you want to know in detail how code this algorithm, here is a small example that we simulate some of the data of two class and implement this perceptron algorithm we just mentioned in R step by step. So you can check out this notebook. You can run it in your local R, just copy paste the code. And there are many problems with this type of algorithm. First, it's a linear classification function, and the algorithm cannot handle nonlinear problem. And also this algorithm is too naive to handle any more complex problem.